6B-5, exponential regression. Okay, so what's different about today's note? There's tables. All right, take your heaven out. Thank you. Okay, we got tables, right? And what's it asking for?
The best fit.
Look at example 1. What's it asking for? What's that blank? To write an equation. Very good. Okay, so we're going from table to equation today. All right. It says given a set of data, right? Because the table is data. Given a set of data, we can write. This should say and not just a. We can write an equation using exponential regression. Says this process will find exponential function that best fits the data given. Okay, so remember how we did scatter plots? Okay, and the dots are kind of everywhere, and you can't really draw a straight line between dots that are scattered everywhere. You know what I'm talking about? So when you do scatter plots, you find the line that goes just about through the middle of all of them. That's kind of how exponential is. Okay, in a little bit. So what we're going to do is we're going from table to equation. So how do you go from table to equation? Where? List and spreadsheets. Okay, so we're going to do that in a second. Don't do it yet because you don't know how to do it. All right? But I just wanted to see if we could remember that. Example 1 says, the table shows the changing population of a city every 5 years over a 30-year period. Write an equation to model the data where x represents time in years. So what's x represent? Years, right? So put an x above it. What's y represent? Population. Okay. Does this model exponential growth or decay?
Growth.
Well, let's look. As the years go on, is my population going up or down? Up, right? So is that growth or decay? Growth. All right, I want to write an equation. What is the equation for exponential? Y equal a times b to the x power. Very good. So write that. A times b to the x. Okay, so you guys told me, where are we going to go in our calculator? List and spreadsheets. Oh, so bad. Okay, let me turn the brightness down a little bit. Okay, we're going to go to list and spreadsheets. So number 4. Remember doing this? Do it with me because it's been a while since we've done this. And it's new, so you need to put it in the calculator with me. Ethan, thank you. Okay, label X column, Y column. All right, so we're counting by 5. 0, 5, 10, 15, 20, 25, 30 for X's. Then we go to the Y's. 227, 238, 250, 266, 282, 296, 309. Now, okay, let's talk about something real quick before you on. You don't know how to go from there on, so don't click anything else, okay? In the word problem, does it tell you that this is exponential?
No.
I mean, I have a question here that says, does it model growth or decay? Well, that question may not be there, okay? So anywhere on here, does it tell you that this is exponential?
No.
Because what else have you learned how to do in list and spreadsheets? Linear. Okay? Well, linear's equation is y equals mx plus b. So we were trying to find an m and a b. For exponential, you're trying to find a and b. So it's something different. Okay? But how do I know if I'm working on a test or homework or something like that, how do I know the difference between an exponential table and a linear table? Huh? How do I know the difference? between an exponential table and a linear table? Well, look at your numbers, okay? Are your numbers consistently going up the same amount every single time? So 227 to 238, what's that jump?
9.
Plus 11. Okay. 238 to 250, what's that?
15.
12. 250 to 266. 16. Is it consistently making the same jump every time? No. Does linear consistently make the same jump?
Yeah.
Yes. Okay. So because this is not being consistent in how it moves up the table, stop. Because it's not being consistent, I know that this is a linear problem. So now we have to go because it's not being consistent, I know that it's an exponential problem. So now we have to go get an exponential equation from lists and spreadsheets. Okay, we want our A and our B. So hit menu. 4. Menu 4-1 is the same. Now when we get here, we usually do this, mx plus b, right? Because we're usually doing linear. But I don't want m and b because that's not the equation that I'm using.
You want linear?
I want, which one does this tell me that I want?
A plus bs.
Are we doing a plus b?
No.
We're doing a times b. And that's also linear. Am I doing linear?
No.
No, so which one do I want?
1.
I want 2. Statistics. Are you in a statistics class right now? No. Which one?
2.
Look at all of them.
A.
Why?
Right? Isn't
It's exponential. What are we doing right now?
Exponential.
Exponential equation. So which one do you think I should click? Exponential. A. So go all the way down, or you can click the letter A. Okay, we want exponential. This part is the same. X and Y.
What's different though?
Enter, enter. Now, scroll up a little bit. Okay. Now it tells me the A and the B, right? So now I take that A and B number and I write it in my equation. So I start with Y equals A, which is 226.41, parentheses my B. Now we're going to round it to 2 decimal places today. So 1.01 to the X. Okay, stay right here in your calculator. Is everybody on this in the calculator? Okay. Now, it says use the model to predict the population of a city after how many years? 50. So years represents what letter? X or Y? X. Okay. So what's one way you could do this? Plug it in. For the what? So I could put the 50 where? In the X spot. Now here's another way you could do this. Okay, I just learned about this earlier and I'm kind of excited about it. You can go to a table from here. So everybody hit Control T. Okay. Everybody hit Control T. Everybody with me right here. Hit enter. We want F of 1. Hit enter. Okay, now here's your real table. Okay. Now how many years do I want? 50. And that's in the X spot. So I'm looking at my X numbers. And I'm going to scroll all the way down to what? 50 on the X's. And when X is 50, what's my population?
30.
Everybody see this number right here? That's my population. Okay? So just like this table right here, okay, it just keeps going in the calculator. It stops on the paper, but if you keep scrolling down, it will tell you at 50 years, this is your population. Got it? Did I confuse anybody?
No.
No. Okay, so let's plug that in, or write it down. So after 50 years, our population is 384. And I'm just going to round. Go ahead and just leave that. That's fine. 384. Just because the table and the paper just has whole numbers, we'll just round that to a whole number. Okay? Questions?
No.
Everybody got it?
Yeah.
How else could you have done that? Plug the 50 where? To the X spot. Okay, either one. Okay, example 2. The table shows the annual income of a small theater company. Is this growth or decay?
Growth.
Are the numbers going up after the years?
Yes.
Yes, so that is growth. How do I get an equation? Plug it into list and spreadsheets. What is my equation? Y equals? Well, is this exponential or linear? Look at your table. Is it going up consistently? No, so it's exponential. A times B to the X power. So we got to go to a brand new list and spreadsheets. Label your X and your Y. 0, 1, 2, 3, 4. 4. Then do your Y's. Do not put commas. Can't put commas in the calculator, okay? 18, 2, 5, 4. 18, 7, 3, 0. 19, 2, 1, 5. Am I confusing you?
Yes.
19, 6, 9. 20, 1, 7, 5. I'll give you time. I'll give you time. Yeah, but make sure you don't put a comma.
It will be quiet.
Everybody with me?
Nope.
I'm just making sure everybody's plugged in. Looks like it. Did you plug it in, Levi? That's what you should be doing right now, with your eyes open. Come on, do it. Okay, we good? You almost done, Cameron? All right, menu 4, 1, but I don't want mx plus b. What do I want? A, exponential regression at the very bottom. X and Y, enter. There's your A and your B, and we're just going to copy it down. Remember, we're rounding to 2 decimal places, though. Y equals 18,264 times 1.0. How do I round that?
3.
Okay, that 5 behind the 2 turns into a 3 to the X power. Okay, here we go, number 3. The table shows the numbers of bacteria in a culture after the given number of hours. Is this growth or decay? Are the numbers going up or down? Growth. Write an equation to model the data. Is it consistent?
Yes.
Are each number going up the same amount every time? No. Okay, so go to a new list and spreadsheets.
Oh, no.
Okay, because we're running out of time, I'm just going to do this one. So y'all just watch me, okay?
Oh, yeah.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, yeah.
Hold on. Watch. 2205, 2270, 2350, 2653, 3052, 3417, 3890, 4522, 5107, 5724. Okay, menu 41A. X, Y, enter. All right. So everybody write your equation down with me. So Y equals, everybody write 1779.4 times 1.12 to the X power. But what does it want? Use the equation, predict the amount of bacteria after 12 hours. And hours represents X. Bacteria represents Y. So how do I find 12 hours? What do I do? Control T, F1, scroll down to when X is 12. There it is. So 6981.02. Then it says, use the table of the calculator, which is where we're at, to predict when the number of bacteria will reach 10,000. So now what do I do?
Scroll all the way down to 10,000.
To what? For the
Y.
Y. How do I know Y?
Because it says the number of bacteria.
Bacteria. Okay, so now I'm looking for bacteria, which bacteria is Y. So when does it become 10,000? Between what?
15 and 16.
15 and 16. Okay, so approximately after how many years?
15.
Yes. Any questions?
No more.
Okay, you guys have a good lunch. We'll practice when you come back. Bye.